Salutations, Swifters, and I hope you're ready to become superheroes of data saving because we are about to learn to save data to the cloud using Google Cloud Firestore in SwiftUI. We'll also learn to use a computed property when creating a data model so that we can minimize hard coding of dictionary data. So let's fire up that Firestore big learning. So, champions, up until now we've been creating a nice sign-up login user interface, but we've only dealt with the authentication portion of Firebase. Now it's time where we'll actually begin to work with data in the cloud. And before we can save any data, we need to first set up a Cloud Firestore database for our project, and here's how we do it. Head to firebase.google.com in your browser, make sure you're logged in and in the console, and then click on your project. Mine is Snacktacular UI, and under the project shortcuts, we see that we have authentication there because we've already set up authentication. But now let's click to expand this build menu and find and select Firestore database. Again, do not select real-time database. That's the Firebase legacy database product. We want to use the latest and greatest, that's Cloud Firestore, which is also a real-time database. And when you click Firestore database, you'll see a screen with a Create Database button, so click that, and you get an option to work in test mode, which doesn't use security rules, or production mode. Since this is a brand new product, there's no harm in working in production mode. We're the only ones with access to this data, and since we've got authentication set up, we do want to use security rules in our project. So I like to work right in production mode on new projects, so let's make sure that production mode is checked. Now we will have to set up some additional access rules, but this is easy. So first, click the Next button. And now you're asked to select the Cloud Firestore location. Now typically, I set the location nearest me, and any of the US East locations should be fine since I'm in Boston. Frankly, the location is likely only an issue if you're working on a project that might be used in a region that has very strict privacy standards where data must be housed in that region. That might be the case for European projects. And do know that you can't change this selection after it's made, but for learning how to use Firestore, location really shouldn't be an issue. Then click the Enable button. Provisioning and setting up a security rules might take a minute. Then we'll see the Data tab, and right now there's no data in our database at all. Now a quick word about Firebase data and how it's stored. So Firebase is a NoSQL database. So if you're familiar with the relational database format used in SQL or SQL, that's not how this data is organized. Instead of the standard database file, Firebase refers to data being organized in collections. If it helps, you can consider that a collection is like a database file, and inside the collection you have documents, which are like rows of data. Now in our project, we'll have a collection called spots, and each spot document is a record of a different restaurant. Now in a NoSQL database, it is possible to have documents that have different data, entirely different fields, including more or fewer data fields, and you can't do that with relational databases like SQL. But having a collection of documents that don't have the same format isn't a good idea in our project. We want our data in a document to match the struct that we're creating to represent the model of that data, and if a document's format doesn't match the struct format, we're going to get an error. This is similar to our previous project where we needed to have our struct exactly match an API's JSON data. If we didn't do that, we also got an error. So here's how data is shown in a running app. And here we've got a struct which will act as the model for this data. And if we look in Cloud Firestore, we see that each document or spot in the spots collection has a unique name, which we want in case we have two or more restaurants that have the same name. And if we click on a spot, we can see that the data inside matches up with the data in the struct. We've got a name, an address, an average rating, etc. We are going to learn how to deal with latitude and longitude coordinates in a later lesson. Now, one more thing that I'd like to show you, and I'll dive into the data that I used in my old Snacktacular project in UI Kit. It is possible to have documents that also have their own collections. So for example, if I click on one of these documents like this one here that starts with 3 Ron LOK, it's like I've clicked on a row in a database if you're familiar with conventional databases. And if I scroll down, I can see the fields in this document, again, name, address, longitude, latitude, average rating, etc. But I can also see that there's a reviews collection here, and each document in reviews represents a different user review of that restaurant. Now to contrast this with another spot, I can click back on the Spots breadcrumb menu, and if I click another entry like this one that begins with 59HQ, I can see that I've got two collections in here, one for reviews and another for photos. Now I won't see any photos in here, but each of these unique collections of characters in the document name here is the name of a photo that I'd find that one of our users have saved, and our app has saved that in Google's Firebase storage product. and Firebase storage is specifically set up to handle larger data items like photos, sound, and video. We'll learn how to use that in later lessons. But for now, know this organization method, collection of documents that can also have other collections of documents inside of those. Now with this quick introduction done, let's take a look back at our Snacktacular database, which has nothing inside it, but which needs security to be set up. So to set up security, we're going to update the access rules in the Rules tab, so click that. Now there is a whole language for setting up complex security rules that you can dive into and learn more about if you have complex security requirements. Right now, we're going to focus in on this line that says that our app will allow read and write if false, which means if false is true, which means it would never allow for read or write, which is not what we want. Instead, we'll allow authenticated users to read and write, so I'm going to delete false and replace that with request.auth, and notice that you get some code completion in the browser too, and I'll specify this should not equal, so exclamation point equal, null, which is the database's form of nil. So if I have a user making a request that doesn't have nil for authentication, then they must be a valid logged in user for my app, so I will let them read and write data. That's it. Click the Publish button. We can click back on the Data tab because we'll want to take a look at the data being added as we add that capability to our app. And now let's head to Xcode and code up the ability to write or store data. So since we'll use a somewhat MVVM architecture for our project, let's first create a model to represent each spot or restaurant. I'd like to create this under the app file, so I'm going to right-click on the Snacktacular app file, select New File, Swift File. I'll name this capital S Spot. Now we're going to use a fairly new SwiftUI library in this struct, so we're also going to import Firebase Firestore Swift. Then below this we'll say struct capital S Spot identifiable, codable, open and close curlies. And then we're going to use a special property wrapper that's part of that new Firebase Firestore Swift library. We write this as @document ID, that's with a capital D, I, and D, and notice what code completion says, a value that is populated in codable objects with the document reference of the current document by the Firestore database decoder when the document is read. Now what this is going to do is it's going to make sure that the unique name that we create for our document is used as the ID property so that we can conform to identifiable. So after this, we'll follow this property wrapper with var id string ? Because initially we won't have a document ID. We'll only get that just before we save the document to Firestore. And also, just like we learned in our to-do list app, we'll use the fact that new documents have nil for their ID property to determine when we need to add a new document rather than update an existing document. Now we're going to add more properties later in this series, but for now we'll just add two. var name equals empty string and var address equals empty string. Now below this we're going to create an additional property with var dictionary, that's with a lowercase d, and this is one of the more architecturally smart things to do when working with Cloud Firestore. You see, Cloud Firestore saves data in a dictionary format. These are key value pairs where the string is the key, the name of the data value, and the value is the data itself. This is sort of like what we saw with JSON. Now dictionary, as I've written it here with lowercase d, is the variable name. I could have called this anything, but since it's of type dictionary, that's a good name to use. I'm going to follow the dictionary with colon and between square brackets, string any with a capital A. This means that the element of the dictionary will be key value pairs, where the key is a string and the value can be any data type. Now dictionaries are common data structures in other programming languages as well, and we can do quite a bit with them, but this is our first encounter with needing a dictionary in an app, and it's just so that we can set up data in a format that Cloud Firestore needs. So Cloud Firestore wants each document saved or updated to be in a dictionary format, meaning with these string, any data value, key value pairs. So we're going to create a dictionary computed property that will immediately create a dictionary for us whenever we refer to the spots .dictionary property. It won't hold or store data values like the properties above. Instead, it will be computed or assembled based on the code that we write. So let's write that code. We'll say open and close curlies, return, and what we want to return is our dictionary. So between square brackets, because that's where we add our dictionary, just like arrays, we'll say the string name of our first key value pair, and we'll spell that just like it is above. So our first key is going to be name, then colon, And the value that we're going to put in this key value pair is going to be the actual property name, so we write name again in here, but no quotes around it. Then we separate our key value pairs with commas, so we'll enter a comma, and the next key value pair is going to be the string address colon, followed by the property name address, and that's it. But when we return to this and add more properties, we'll also expand the computed dictionary property so that it returns a dictionary with the new values as well. Now, in order to create a new Spot document, we need to enter this into the app, so we'll need a new view. So let's create this below the list view. I'll right-click there, new file. This will be a SwiftUI view, and let's call this Spot Detail View. And below the struct definition, let's create a new value to hold a spot. We'll say @state var spot with a lowercase s, colon, spot with an uppercase s, and we won't initialize this because we're going to be passing the value in from the list view. Now we'll also want to dismiss this view and head back to the list view at some point, and we know what we need. @environment, not environment object, and between the parens, \dismiss, followed by private var dismiss. And we have an error here, and we know why, because we now need to update our preview provider so that we pass in a spot. So I'll backspace over the end of the spot detail view, then select the new correct version that wants a spot to be passed in, and I'll pass in capital S spot with open and close parens. That just creates or initializes a brand new empty struct of spot type for us to use when using the live preview from this file. Now I don't want to start with a text view. I'm going to delete that and replace it with a VStack, open and close curlies, and inside we'll add a text field. Select the option with the title key and text. The title key will just be the string name, and that's what will show up as a gray placeholder in this empty text field. Then tab over. The text needs to be a binding value, so we'll say $, then lowercase s spot dot name. And below this we'll add another text field with the string address as the title value and $spot dot address as the text value. And I want this name field to have a .font modifier of .title, and the address field will have the font of .font of .title2. Then I want to apply some modifiers to both of these fields. So I'm going to command click on the first field and select group from the quick action menu. The curlies are only around the first text field, so I'll cut the text field with its modifier below and I'll paste it between the group curlies. Then below the group curlies, I'm going to set text field style to rounded border, and I never think that that's dark enough. So we'll use the overlay technique that we learned back in our first app to darken this up with .overlay, select content, return for the trailing closure, and in here we'll add a rounded rect view with a corner radius of 5. Below the rounded rect we'll add a .stroke modifier, select the option with the content and the line width. If you hold down the option and press enter, you'll get both of those parameters. And for the content, I'm just going to enter the color .gray, but I always think that that's too dark too, so right after the word gray, I'm going to say .opacity, passing in 0.5 to lighten it up a bit, and we'll set the line width to 2. Then we'll add some padding, but in between the parameters, we only want this to be horizontal, and below this, we'll add a spacer. Now we're about to add toolbars, but this view is inheriting the navigation stack from the prior view. But in order for the navigation stack to show up in the live preview when viewing from this page, which I'll need to see the toolbars I'm about to enter, I need to enclose the preview provider call to spot detail view in a navigation stack. Now let's add the toolbar after the closing curly of the VStack, which is the closing curly just below the spacer. And I'll actually first set the .navigation bar title display mode to .inline so that I don't have a big white space at the top of the view. And the look I'm going for here is that I don't want a spot that has been added to have its name or address subsequently edited. This is just because I'll be getting the name from Apple's database, which I trust. Now we'll do that in a subsequent lesson. For now, we're just going to enter random names and address data. But I'll assume that if Apple's data is accurate, then I don't want anyone to change the name of a restaurant after it's been saved. That'll also prevent the reviews from one place ending up in another place. So if the spot that's currently in the view is not a new spot, meaning its ID property is not nil, then I'll show the back button. Otherwise, I'm going to show a cancel and save button instead. And here's how to do that. I'm going to add a .navigation bar back button hidden that accepts a bool as its optional value. So I'm going to hold down the option key while I press return. That will add that value. I'm going to pass in as the bool spot.id = nil. So if this is true, then I'm going to hide the back button because it's a new value and I want to show save and cancel, not the back button. Then below this, I'll add a .toolbar modifier with content, press return for the curlies, and inside I can add a conditional if spot.id double equals nil, open and close curlies. This means that this is a new spot, so I should show the cancel and save button. So between the curlies, I'll add a toolbar item view with placement and content. Hold down the option while pressing return to add the placement parameter in there. And for the toolbar placement, I'll say dot cancellation action tab, press return for the content to be a trailing closure. And in here, I'll add a button with the title and action. The title will be the string cancel. Press return for the action to get the trailing closure. And in here, I'll just dismiss. Don't forget your open and close parens. Then I can highlight and copy this whole toolbar item view and paste it below this view. Make sure that you match up the curlies properly. You still need to be inside of the if blocks curlies. And I'll change the placement to dot navigation trailing, the button string to save, and I'll put a comment just above the dismiss that says add save code here. So this is a good start, but because this is going to be in an MVVM structure, we also need to create a view model class. I'm going to do that right under the spot, so I'm going to right click on that, select new file. This is a Swift file, not a SwiftUI view, and I'll name this Spot View Model. Now we're going to be working with Firestore code, so we need to import Firebase Firestore. Then we'll declare our class with class Spot View Model, upper camel case, colon, and this has got to be an observable object, open and close curlies. And for now, we have one published property in here at published var lowercase spot equals uppercase spot, open and close parens. That'll just create an empty instance of the spot struct. And now we're going to create a function to add a new spot or save updates to an existing spot. Now I just mentioned in the final app, I don't want us to be able to edit a spot once it's been added, but part of the purpose of this lesson is to show you that we can add a new document or update an existing one, so we'll write this function to do both adding and updating, even though in the final app, we'll only use add. That'll mean that the code that we write here will be useful as a template for other parts in the app where we'll also add and update a document. So before we write this code, let me show you the completed function and walk you through what it does. So we're going to save a spot, which is a document. In our case, this is a restaurant, and we could have given this function a more generic name like save data, but there's just a bit of code in here that's specific to the spot, and for teaching purposes, I want us to see clear modifications that we'll do in this function when we're using the code in a later lesson. So we pass in a spot, which is of type spot. That's the struct that we just created, and this function is marked with the async keyword. Remember, that means that when this function runs, it's not going to hold up the rest of the app while we wait for the result of the save to come back. Now, I'm also returning a value in this function that's a bool, and this value is going to be true if we saved successfully or false if we threw an error. Then, whenever we work with a Firestore database, we need to create an instance of that database so that we can refer to it in our code. So I'll do this by saying let db equals firebase.firestore. Then we have an if let else statement. Now, the first part, if let, checks to see if the spot's ID property is nil, and it shouldn't be for existing spots that need to be updated. So if we create this ID constant, then spot.id doesn't contain nil, so we're working with a spot that already exists, and we just need to update the data in this document. Now to do that, we use this do catch clause here because the code can throw an error. So I'll preface this statement with try, since it can throw an error, and await, since this is an async function that won't hold up the execution of our code. And we'll once again see in code completion that Xcode will tip us off that we need to include this. Then we say db, this means go into our Firebase database, dot collection, it means go into the collection, and we pass in the string of our collection. Our first collection is called spots. Then dot document, passing in the variable ID. So we're in the spots collection, then referring to the document named with the ID of the spot ID property. Now that's the name of the document, and Firebase will name this with just a jumble of characters, sort of like the UUID. Now we already have that ID in here, so it's not creating a new one. It's already been set up. We're referring to it. And this method at the end of this is where we do the actual saving, .setData. Now when we enter this in code completion, we'll see that this accepts a dictionary. And hey, we pass in our computed property spot.dictionary, so this will work perfectly. Now, even more great about the way that we set this up, if we ever update our spot struct, and we will be adding properties to the struct in later lessons, we just update the struct file. We don't have to make any changes here since we refer to the computed dictionary property. In Google's tutorial code, they actually show that you can hard code the dictionary right in here. You don't want to do that. That's not very MVVM. The way we've structured our code is much better. Now, if this works, we'll print a message and we'll return true. Otherwise, we'll print the error and return false. And then in this else clause, we get here if our ID property is nil. nil, which means we need to add a document. We're creating a new spot. We're not updating an existing spot. So we don't set the data on document ID. Instead, we simply call add document after the spots collection, passing in our dictionary. And this function will automatically give our new document a unique name. That's that jumble of characters that looks like a UUID, and that will automatically be put into the ID value that has that document ID property wrapper in front of it. We don't need to do anything else to make this happen. Firebase handles it for us. And again, if this works, we'll return true. Otherwise, we'll return false. And that's it. Now, this function is fairly reusable. I've underlined the areas in green that you would change if you're using this in a different but similarly structured project. You'd probably want to give the function a different name, since you're probably not saving something called a spot, and you're probably not passing in something called spot. And these collection parts will probably change, since you probably don't have collections that are named spots. You should have a computed property called dictionary, but you're not going to be calling that on something called spot. Now, if you had several layers that you were going down to save a document, say a collection, then a document, then a collection again before you get to the document, you'd just have a longer path here. And we're actually going to see this in a later lesson when we save documents to a reviews collection that's inside of an individual spot document. But that collection name shows up here in two places, here and here. And another minor issue, I hard-coded the name of the collection in a print statement. You could easily change that as well. Now, it's definitely possible to write an even more reusable function that passes in the collection document path, but I want to keep it the way that it is and modify this function because I think it'll be easier to understand how more complex databases work when we get to saving reviews and saving photos. We'll expand on this later on, but this should work great, so let's code it up. So back in the spot view model class, we'll declare this function with save spot between parens. Spot is the name of the value we're passing in, colon, and that's of type capital S spot. This is an async function, and we're going to draw an arrow because we're going to be passing back a bool, open and close curlies. Then we declare an instance of the Firestore database so that we can work with it in our code. We'll say let db equals firestore.firestore. That has open and close parens at the end. Now you may get an error in here that says cannot find Firestore in scope. I'm going to put a bonus video up here on how to deal with that error, but we can ignore it. It's actually a bogus error. And in that bonus video, I'll describe the comments that I've written here. Then we're going to check to see if this spot has already been saved. So we'll say if let id equals spot.id, open and close curlies. If that's true, the spot must already exist, so we're going to save it, and we're going to do that in a do catch clause. Inside the do portion, we're going to start this with await, then I'll enter db to refer to our Firestore database, dot, select the collection option. We're going to pass in the string spots, lowercase s, because that's the name of our collection, then dot document. Between parens, we put the name of the document, and that's going to come out of our ID parameter. No quotation marks around this. It's coming right out of the value. This is going to be that jumble of characters that's the document name. Then to update this document with the data that's in the spot that we pass into this function, we're going to say dot set data and select this option with async in throws. And look at the value that this accepts. The data value should be bracket string colon any. That's a dictionary. That's the same type as the spot.dictionary property that we created, our computed property, in our spot struct. So that's what we're going to pass in here. Now remember, if it's async, that means we've got to have an await keyword out front, and throws means we have to have the try keyword out front. I made a mistake and didn't add the try. Sorry about that, but we'll fix that error in a bit. Then down in the catch clause, if we throw an error, we'll print angry emoji error, could not update data in spots, string interp, passing in error localized description. And above this, if things work properly, right underneath the wait in the do clause, we'll print, and I think it's really cool that we're updating data, so I'll put in cool emoji, data updated successfully. Then, after the if clause, we'll say else, open and close curlies. If we're down here, we don't have an ID, so this must mean that we've got a new spot to add. And sorry, I spelled good wrong. Now down here in the else clause, the code is going to be very similar to the code above. We've got a do catch clause. We're going to start out in the do with await.db collection, passing in spots, but this is what's different. We'll say dot, and we want to say add document, selecting this option with async in throws. So this is going to create a new document for us, and it's going to give us that document ID that's going to be the document name. So press return to accept this. Notice what this accepts. It accepts a dictionary. That's in brackets the string colon any. That's exactly what we're getting back with our spot.dictionary property. Enter spot.dictionary as the data we're passing in. And again, I forgot to add try out front of await. We'll fix that in a bit. Now for the catch clause, I'm just going to copy the error that I wrote up here, paste it down below, but I'm going to change this so that it reads could not create a new spot. And I'm also going to copy the print statement with the cool emoji up top, paste it down below. But since this is creating a new document, I'll say data added successfully. And since this is a new document, I'll put in baby chick emoji. Now, one last thing, critically important, although Xcode would warn us if we forgot this. Remember, we're returning a bool value here. The bool is going to be true if we successfully saved. It's going to be false if we threw an error. So in my first do clause, after I print my success statement, I'll say return true. In the catch statement, I'll say return false. And I'll do that in the else clause as well, in the do part saying return true, and in the catch, return false. And that's it, Swifter. Again, we're going to return here later to fix the try that I forgot to add in front of the await statements. And you can ignore the error that's showing up on this letDB line. It is a bogus error. And again, I'm going to describe that in a bonus video. So now we need to instantiate the new Spot ViewModel class as an @state object, an environment object in our first file. That's the app file. So click on the Snacktacular app file in the project navigator. And remember, we always declare the first instance of an observable object using the @state object property wrapper. So we'll do that in the struct below the UI application delegate adapter line. We'll say @state object var spot VM lower camel case equals spot ViewModel open and close parens. Then below this, under the call to login view, we'll add .environment object. Again, make sure it's environment object and not environment, passing in lower camel case spot VM, the instance we just created, and this provides access to that object in our view hierarchy. And now we're ready to use this new view model as an environment object in our spot detail view. So let's click back on spot detail view, and after the struct, we'll set up our environment object, and we can do that with @environment object var spot VM lower camel case colon spot view model upper camel case, and there are no parens here. We're not creating another one. We're just saying that our environment object spot VM is of type spot view model. And we should also acknowledge this down in the preview provider. So below the spot detail view, we'll add .environment object passing in upper camel case spot view model with open and close parens. And now we're ready to add our call to save spot. So we can highlight and delete our to-do code in the save button action. And since this is calling an async function, it needs to be in a task block with a capital T. And in between the curlies, remember, we set up save spot to return a bool. So we're going to get that bool by saying let success, that'll be true or false, equals, we have to use await since we are calling an async function, and then we'll call spotvm.saveSpot. See how this is an async function in code completion? That's why we needed to put this inside the task block and precede this with the await keyword. And we'll pass in lowercase spot, then if success, open and close curlies, else, open and close curlies, and in the else, we don't have a successful save, so we're just going to print out angry emoji, dang, error saving spot. But if we have true in success, then we'll just dismiss this since we saved fine. And that looks great. So now we've got to update our list view so that we can present the spot detail view as a sheet when the plus button is pressed. So let's head over to our list view file. And since we're going to present a sheet, we need to create a bool to do that. So right under the struct definition, we'll say @state private var sheet is presented and set this equal to false. Then down in the action code for our button, we've got a to-do comment in here. We can delete that and replace that with sheet is presented .toggle. Then my sheet needs to go below the toolbar modifier, so I'll collapse that to make sure I'm putting it in the right place. And here I'll say .sheet, select the option with is presented in content, press return. Is presented as a binding variable, so we start that off with $, sheet is presented, tab over, press return for trailing closure format. And when we present a sheet and we want our toolbar to show up, we want to make sure that the view that we're about to call is inside of a navigation stack. So we'll add navigation stack, open and close curlies. And in between here, we'll call spot detail view. And since this is going to create a new spot, we're going to pass in capital S spot, open and close parens. That'll be an empty spot. Now, if we try to build and run, we're going to get the errors that I mentioned before. I forgot to add try in front of the two functions that potentially throw errors that are inside of our save spot function. So we've got to head back over to our spot view model and correct that. Remember, you have to enter try before the await keyword. Now, despite this error showing up in the letDB equals line, this will build and run. That letDB line error is one of those bogus errors that sometimes shows up when using Swift packages. It's very common in Firebase. Again, check out the bonus video in the playlist for more info on this. But we see it's hammer time. No error, successful build. And so here we are in our error-free app up and running, and in the background, I'm going to pull up the data tab of our app's Cloud Firestore page in the console. There's currently nothing here, but now in the app, I'll log in, and I'll click the plus button, head to our spot detail view. I'll enter a new spot, Pino's Pizza on Beacon Street, Cleveland Circle, one of my favorites. Be sure to try the Sicilian slices. Click on save, and we don't see anything in the browser. But if we look at the console, we see the baby chick data added successfully message. So let's refresh the page in the browser and ding dang database, will you look at that? We now see that we have a spots collection and our first document is in there. It's for Pino's Pizza. Swifter, you saved data to the cloud, you awesome one. We see that Firebase created a unique document name for this first document and it put it in there automatically. Nice! Let's head back to the app, add another spot. This one is for El Pelon, a favorite for tacos among Boston College students, although I see that we want to remove the autocorrect because it just renamed El Pelon, not what we want. But that's on Commonwealth Ave in Chestnut Hill. Click Save, and it shows up automatically. No refresh required this time. So this is working great. We learned how to save data to Cloud Firestore. In our next lesson, we'll learn how to load all of our data and show it in a list. Until then, continue to hack.